Hi, welcome to another edition of Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Steve Smith. Hey, Steve, how are you?
Good. How are you doing?
I'm doing great. Thanks for coming back on the show. Been on the show a few times.
Yeah, it's been
And
great.
today we're going to talk about some more architecture. We have you on the show every time we need to sit back and think about how we architect apps. I think this will be very informative. And we're going to talk about modular monolith architecture.
That's right.
Before we dive into that, why don't you briefly introduce yourself for the few people that might not recognize you?
Sure. My name is Steve Smith. I go by Ardalis online, so you'll find me ardalis.com or at Ardalis, various places, and GitHub and Twitch and YouTube. I am a co-founder of Nimble Pros, which is a small consulting shop that specializes in dotnet architecture, training, and consulting. And I've been a Microsoft MVP for probably 20 years, I think, in ASP.NET and developer technologies, and really love helping customers build cool things with the Microsoft stack.
Cool. So, what is modular monolith? And I guess the question is, what is it? Why was it invented? When was it invented? What problems is it solving? And then how do I do it? All
Sure.
in an hour.
Yeah, well, we're gonna give it a high level overview, and I'll give you some resources where you can learn more for sure.
Excellent. All right. So we got some slides because we do need to talk about the theory before we just dive right into the code, I think.
Yeah, I think that'll help. So I just threw these together like in the last hour. So if there's any problems, I'll apologize in advance. But I just wanted to have some visuals, so I wasn't just a talking head the whole time trying to describe the concepts here.
Mm-hmm.
So let me find there we go,
Our
PowerPoint.
first
And
comment, Tej is commenting on your new hairstyle.
yeah, the slide template's still got my army haircut, but I've been growing it out for almost 2 years now, so it's a little bit longer. It's got the ponytail and everything. But
Excellent.
yeah, it's definitely a change. All right, so let's start. Let me get my shilling and promoting out of the way first. I've got a couple of courses on this topic on Dome Train, and they are available at the URL here, or just go to dometrain.com. You can actually get 20% off with my name, Ardalis, on there. And this is going to be, I think, like 8 hours worth of material. The last couple modules I'm just wrapping up for the deep dive, but they'll be done probably like tomorrow. Everything else is all good to go, and there's sample code for everything, which we're going to take a quick tour of a little of that here today. And then as a free resource, we're actually doing a webinar from Nimble Pros this Thursday, so on February 22nd at 1 p.m. And you can sign up for free at the URL here, and they're all recorded. So if you're watching this later on YouTube or whatever, you can still go find the recording of that webinar if you want.
Okay.
All right. So software architecture is what we're really talking about today. And there's a bunch of good material on this online, of course. There's a great book called Fundamentals of Software Architecture, which I highly recommend. And one of the things they describe in the book are the laws of software architecture. And the first law, which I love, is everything is a trade-off. And as a consultant for decades now, I know the consultant mantra of "it depends" as the answer to every question. And that is so true for architecture too. So like if somebody says, well, what's the best architecture? The answer will inevitably be, well, it depends. It really depends on what you're building and who the audience is and how you expect it to grow and things like that. So the simplest architecture that pretty much every application begins its life as, if you type, a Hello World app, it's going to be a monolithic architecture. And all that means is that it's an application that is organized and deployed as a single distributable. So in Visual Studio, it would be, file, new project, spin up a console app, or even an ASP.NET Core app, and then hit F5 and you're running it. That's a monolithic application. It has one assembly. When you deploy it, if you deploy it somewhere, it has one DLL or one exe that it needs in order to run. Okay. Now, the problem with the monolithic architecture, and the reason why we have a lot of other different types of architectures, is that without a whole lot of additional, well, not necessarily a lot, but without some more organization it can devolve into this so-called big ball of mud architecture, which basically just means that things have kind of grown organically, and there hasn't been enough time spent to really design how those things should interrelate with one another. There might be a lot of duplication or technical debt, or things that are depending on each other in ways they shouldn't. And so frequently, you're going to have at least a little bit more organization than a single project in your applications. Things that we're building professionally for, especially for enterprises, but even for small and medium businesses, they're usually going to have more than one project in a typical application.
Mm-hmm.
So a really common approach that almost every application uses these days, it seems, is this layered architecture. And a layered architecture is sort of a subset of a monolithic architecture, because typically this is still deployed as a single unit, but now we're going to logically separate it into these different layers. And so the UI, the user interface, the business layer, the data access layer, those things are each going to be different projects or assemblies. And this is often added just to improve the design, because it gives you the separation of concerns, right? We don't necessarily want to mix data access details with user interface details, because those things change at different times for different reasons. And so this definitely improves the design and the maintainability of a monolith that otherwise was just a whole bunch of code in one project.
Yeah, it gives you some reusability, easy to swap out the UI without having to rewrite
exactly.
or change the business and data access layer.
Right. And most developers have been coding professionally for a while, have at least seen this, and are familiar with the idea. And it gives you the ability to specialize a little bit as well. Sometimes you'll have someone on the team that's really good at the data access, and someone else maybe is really good at the UI. And so you can kind of focus a little bit like that as well. And in much larger applications, it might even be different teams responsible for some of those things.
Mm-hmm.
Now, these are typically going to be separated out into different projects or assemblies in Visual Studio. Sometimes they'll all be in a single deployment unit as folders. That doesn't really matter so much. You can do layered architecture using something like ports and adapters or clean architecture, which I've spoken about before on this show, and I'm a big fan of. But at the end of the day, you're still largely separating things by whether it's a UI concern or a infrastructure concern like data access, or business logic, or your domain model if you're doing domain-driven design. And so although the dependencies might be different, the idea that we're separating things at the highest level by technical concern remains. All right. And so the problem with this layered architecture approach is that it doesn't offer enough modularity at the feature level. Right.
Okay.
And so imagine you have an application and it has a bunch of features like users, cart, orders, the things you can see on the screen. Now you've separated out into layers. And so on the UI, there's different users, pages, or screens or what have you. And then in the business layer in the middle there, you've got a user's service and a cart service, and those have different methods and things on them for managing those things. And then the bottom layer in the yellow is the data access that kind of hides away whether or not we're using Dapper or EF Core or something else. And so the dependencies between these start out pretty nice, right? If you go to log in, you go hit the login method on the business service, it goes and calls some data layer to log in, and that's great. But now when you go to deal with your shopping cart, well, it needs to know some information about who you are and load up the cart, and then it needs to talk to its services and store things. And then you create an order from your cart, and it needs to go and get the information from the cart and maybe see what the user's default address and payment details are, and then create the order. And then inventory wants to get involved, and it needs to talk to orders too, and shipping needs to talk to all the different things. And at the end of the day, this whole thing starts to become a little bit messier than you would like, and certainly not as modular as you would like. Like now you come from this, and it's been a couple years since you started development, and somebody says, hey, we should really split this part off into a separate microservice, right? Maybe we want to take the shopping cart or the users or orders and turn it into a microservice. But it's hard because it's not just one vertical slice that everything is in self-contained. It's got all these different things that are reaching in and hitting its services or its data layer or what have you. And I'm not even showing you the data model in which any one of these could be joining on or querying against any of the others' tables, right? Which is another big problem. And so the biggest issue here is all the dependencies that cross between these different features. And that makes it very difficult for you to think of these or work with these different features as if they were modules, right? So when we add another feature, and suddenly we're going to add, I don't know, let's say notifications, right? It would be nice if we could just add another notifications module and plug it in like a Lego and have it just work, right? And not have to, hardwire and weld it to every other module that it might have to work with.
It's going to be interesting to see how to pull that off.
Yeah, it's not a panacea, right? There's some overhead involved in how we're going to do it, but there are ways that you can make this better. So, with this layered approach, because of all the cross dependencies, you often end up with this spaghetti code, or at best, lasagna, if you will, if you need a pasta metaphor, code for this, where everything is sure it's in these different layers, but there's not really anything keeping those different features or those different things that we would like to have be modular from talking to one another.
Right.
And the existing keywords that we have in C# are limited in terms of how you can protect access to things, right? So we've got public or private or protected and internal are the general ones we use. And if you have a module, if we're doing this all with different projects, and we jump back to here for a second, right? The user's module here, this DLL, is generally, or actually this whole thing is usually one assembly, this whole business services layer. Those things are usually going to be public because they need to be callable from all these things up here, right? And so because this service is marked as public, any one of these other services can get to it. And so there's nothing really preventing developers from doing this exact thing. What you could do, and maybe it would work a little better, is mark some of these as internal, and then use the internals visible to say that it's only visible to users, right? And then you can kind of like only give certain calling things the key. But even that would presuppose that each one of these was in a separate assembly. And this big shaded box here represents an assembly, right? So if we give the UI assembly access, then the whole UI assembly has access is the problem here,
right?
Even if we use internals visible to. All right, but that's sort of a hint about where we're going. So the solution is to have these different modules that are sort of vertical slices through the functionality. So within each one of these modules, we have the user interface logic, we have the business logic or the domain model, and we have the data access, and we even have a separate persistent store. So they might use the same physical database, but they're going to have their own different set of tables or a different schema or some way that they can show that these are the things that we own, and the other ones are owned by some other module. Does that make sense?
Yeah.
All right. And so there's different ways that you could handle modularity. And one of them is microservices, of course, right? So microservices, when you do them right, they check all the boxes, right? That we now have a separate cohesive set of services that are all about one feature, like users. We expose those things through a set of public APIs. Everything else is behind our boundary so that nothing else can see it. And ideally, we've got our own database as well for each one of our microservices, and they only communicate with one another through these public interfaces or through some type of messaging system.
Right.
So these could do the job, and a lot of people are using microservices these days. They're certainly still at the top of the hype train. But the problem with microservices is they are expensive, right? They're expensive to build correctly, especially if you're starting with them, as opposed to evolving to them. They're expensive to deploy. They're more expensive to host. They're expensive to monitor. All of these things make it so that microservices aren't necessarily a panacea. They aren't necessarily the thing that you want to use for every application, even though it is nice to be able to put that on your resume and say, hey, I built this cool thing with microservices. So we could do microservices, right? But one of the problems with microservices is if you don't go to the extra mile and make sure that they're very independent. What if you decide, hey, we can't really afford, or we don't really want to have separate databases for every microservice. Let's just have them all share a database. Well, then you're moving into this zone of pain over here. So let me describe this graph for a second. Across the x-axis here on the bottom, this is the number of things you're deploying, right? So monoliths, it's one. Microservices, it's more. And then the modularity, monoliths generally, and including layered style monoliths, are not very modular. But the modular monolith has more modules, and microservices are by definition modular, right? But if you don't keep your microservices independent from one another through any number of mistakes you make in your design, like a shared database or like synchronous dependencies and API calls between them, then you're going to end up with this distributed monolith, which means you have all the problems of coupling and other issues that monoliths have, and all the difficulties and expense of having a distributed system. So you really don't want to go there. What is a better solution, I think, in many cases, and again, it's all trade-offs, it's not a panacea, is if you're starting from scratch and you think you might want microservices, start with a modular monolith.
Hmm.
Or if you already have a monolith and you think you want to move toward microservices to get away from your big ball of mud tangled mess that you found yourself with, again, it's easier to move in just one step here than to try and go diagonally and go all the way to a distributed application. Just try and get modularity working in your monolith. And then if you still think that some of those pieces would do well as microservices, you can spin off individual modules. You don't have to say everything deserves its own service. You could say, well, this module is critical, it needs to scale independently, etc. We're going to
Hmm.
move that one to a microservice. Everything else can still be in the monolith as separate modules.
Right.
So that tends to be a safer and more likely to succeed and faster path toward building your application than trying to build microservices from scratch.
Right. And so Tej has the same question that I had. So is communication between the modules, is that just API calls?
You could do that, and that's a common thing that one does in
Okay.
microservices. I don't recommend it necessarily in microservices because it gives you a dependency in real time that requires both those services to be up. And so it makes it so that if any service is down, all the other services that depend on it are also down, and that cascades very quickly. So no, the short answer is that's not what I would recommend. Now, in a modular monolith, we have the advantage of running all in one process. And so we
Hmm.
should take advantage of that. So instead of using an API call, which is an out of process call, requires serializing and deserializing, going over the network and all that, we can do something like use the mediator pattern and maybe Jimmy Bogard's mediator library to create essentially a API call, but it's going to be just a method call, right? And
Okay.
so instead of having to go over the whole HTTP stack and deal with security and everything else, we're just going to use mediator to make our communication between modules pretty simple for a lot of cases, right? There will be
Well,
other cases where
basically,
we still
yeah.
may use messages, like out
So
of
instead
process
of the,
messages.
sorry to interrupt.
Go
So
ahead.
instead of the cart, when it wants information on users, instead of the cart talking to the user's data and talking to the user's code, it basically asks the user's module for some information.
Right.
However, the user module does it, that's fine. And then the
Mhm.
user module sends back the information the cart needed. And right, so it's like an API call in that you
Right.
just ask a question of a blob of code somewhere, and that blob of code gives you the data you were looking for. You never get to touch it. You don't need to care how
Right.
it's written or what it's doing. So you have that. It's distributed in that sense, right?
That's right. And
Okay.
so each one of the modules needs to have a set of contracts that it supports, and these will be public. And I put them in a separate project, a separate assembly, because that way everything can depend on those contracts and not have to have cross dependency between the modules. Because if we look back here for a second at this diagram, if you have two things that need to depend on each other, which I don't
Yeah.
think I'm showing here, but just imagine for a second that this cart module needs to depend on orders, and for whatever reason, orders also needs to depend on cart. Well, if they're in separate projects, you can't have a project dependency that goes in two directions. You can't even have a circular dependency that tries to do it through a series of hops.
Mhm.
So you have to have to fix a circular dependency, you have to introduce a third project and have both projects depend on that new one. And that's exactly what we do with our modularity here is we
Okay.
make it so that each module will have a separate project that is its contracts, and those contracts are just DTOs, right? They're messages. So it'll have commands, it'll have results, it'll have DTOs, the types of things that represent how someone is going to ask for and get back information from that module.
Mhm. Cool.
Any other
That's
questions at the moment?
not at the moment.
All right. So then, what if you could have all these modules in one monolithic application? It would look something like this, right? We'd have a host that's our entry point, and then it would load each one of these modules at startup, and then the modules would be responsible for their own user interface and everything else. So the idea here is that these modules are independent from one another. And so you could swap one in and out. You could change the design of one or deploy one and not have to deploy the others unless you're changing those contracts, right? If you change the contracts, then both sides of the contract need to be updated.
Mhm.
Um, they can be worked on by separate teams. They're feature specific. They should represent a bounded context, which is also true for a microservice. So if you're building microservices, each one of those generally is going to represent a bounded context. They have their own persistence. They can be organized appropriately. This is like all the things that you would tick the boxes for microservices are also true for these modules that are living inside of your monolithic application.
Right.
So let's compare them, right? The modular monolith is logically independent. Microservices are logically and physically independent. They're deployed separately. But because of that difference, modular monoliths are easier to deploy, cheaper to host, easier to troubleshoot, and microservices are the other end of those things, right? But the trade-off is that your modular monolith is still a monolith, right? So
Right.
you can't scale it as a bunch of small little units. You scale the whole thing, right? So it still can scale both vertically and horizontally, but not as individual little pieces. And it's less available for the same reason, right? If any part of that modular monolith goes down in a way that crashes the app, the whole app is down. Whereas with a microservice, if something fails with one microservice, it might only take down, or should only take down, that microservice and not all of the services.
But I think even for a not terribly complicated application, it would seem that it makes it easier to organize it.
Yeah, for sure.
All the functionalities in a module as opposed to scattered throughout the code.
Yes. And to that point, having the organization in each module also lets you decide how you want to organize the code in that module. And it might be that you choose differently in different scenarios. So I mentioned earlier clean architecture, which I'm a fan of. It's a good way to organize your code so that it makes sure that it's unit testable and it doesn't depend on infrastructure. So if you have really complex modules that have a lot of business logic in them, that might be a good choice. So you can write a bunch of unit tests, make sure that they're good to go. Your domain model is appropriate. But you might have other modules that are pretty straightforward, and maybe they just do CRUD, or maybe they're not as complex. You could use vertical slice architecture, which is also pretty popular these days. And the idea with that architecture is that you try and put all the pieces that you need in one place, right? In one folder, sometimes even in one file. So if you've got an endpoint and it needs a DTO for a request and a DTO for a response and some service, instead of having those in 4 or 5 different places all over the solution, they'd all be in the same folder or even in the same file. And some developer that needed to work on that could see everything in one place. And so there's good trade-offs there as well. And different teams could make different decisions about that organization on a per module basis, just like you can with microservices.
Right. So Pablo says, does not agree that monoliths are less scalable.
Yeah, they're less individually scalable, right? So if I have a monolith for a shopping system, and the thing that needs to be the most scalable is the checkout module because it has to do payment processing or whatever, right? If I build that as a monolith and I need that one to scale, I need to scale the whole app, n times, right? So now on Black Friday, I'm hosting 10 or 20 of the whole application. Whereas if I build it with microservices, I might have to have 1 or 2 of all the usual services, but the checkout service has 20 instances.
Okay.
And so that's the difference, is that you can't granularly scale different pieces of it.
Okay.
I hope that he agrees with that. That's what I meant.
All right. Sounds good.
Cool. All right. So summarize here, and then we'll show some code. Monoliths often run into the problem that they don't have enough logical separation between different features. They're not modular typically. And so layers can help, but they're not usually sufficient for larger and more complicated applications. Microservices are an attempt to solve this problem, but they bring with them a lot of complexity and expense. And so these modular monoliths, I think, can offer a kind of a Goldilocks solution where they're in the middle, right? They don't have some of the problems of monoliths. They don't have the complexity of microservices, and I think they fit the bill for a lot of enterprise applications. So folks that want to learn more, you can grab this course. It's long. There's a lot there. We're going to look at a little bit of it right now, and you can always contact me at nimblepros.com if you have questions.
Cool.
All right. So that's it for Death by PowerPoint. And here we are now in Visual Studio. So what I thought I would do is start with the entry point of the application and let people see just like how slim that host application really is. So this is the web app. This is just a standard ASP.NET Core application. And there's nothing in it except for program.cs and I've got an HTTP file in here that I'm going to use to exercise the endpoints. Now, this application doesn't really have a proper front end. It's just a bunch of APIs. So you could put Blazor in front of it or whatever front end you prefer, and it doesn't really matter. So that's the part of the idea. Now, there are ways that you can make sure that your front end of choice is also modular, but they're outside the scope of what I'm trying to cover here. The course was long enough as it was. So in this program.cs, right, we're going to just create a logger. We're going to create our web app. We're going to configure fast endpoints, which is what I'm using for the APIs. This is a great library that I really like. It's sort of a replacement for my own API endpoints library that I know some people are familiar with, but it essentially lets you have a class per endpoint in your application, which I really like. Okay, so then in here, this is where we add the modules. So each module has an extension method that is responsible for configuring all of its services. So one of the goals I had when I was building the sample app was to have as few touch points as possible in the host, so that when I add a new module, I don't have to go and add things like in 10 different places, like, add another controller and add another set of views and go configure this and configure that, right? I didn't even want to have to add additional middleware if I could help it. And so basically everything is just these single calls. So like the book module, this is it. This is the one line of code that you need for the book module to work. And then down here, this is it for middleware, right? I've got authorization stuff and I've got fast endpoints, and that's it. Now we could add other middleware if we wanted to for diagnostics or things like that, but all of those things would be cross-modular. They wouldn't be like for a module typically.
Okay. Cool.
Make sense? All right.
Yep.
So let's look at a simple module. Let's look at the book module, and that's the one that I started with in the course. And it's using EF Core, so it's got some migrations here to wire things up, and it's got a couple of endpoints here. So the main entity here is this book. It's got an ID, title, author, price, and a few endpoints where we can do CRUD operations on a book. So this is what a fast endpoint looks like. It just defines a class that inherits from an endpoint of request, comma, response. So this is the request type. This is the response type. You can chain them together up here so that you can just see them all together. It's a really nice way to organize endpoints, I think. And so the request is just, here's the things that you want your new book to have. And then the response, sorry, this is a validator. I couldn't see it because this is too small. But you can add a validator to it as well. This uses Fluent validation. So it'll validate the book. And then the response from this thing was just the DTO. Okay. So you can do CRUD operations. So let's just look at that. So over here, let me restart the app and jump this to the top. All right. So when the app starts, didn't kill the wrong one. One sec. There we go. When the app starts, one of the things you'll see is that each module tells you that it was registered successfully. And then fast endpoints will tell you that it registered so many endpoints. And then I've got a background service that's going to just ping every little while saying that it's sleeping. We'll see that in a minute. All right, so if we just want to get all the books, we can hit this request here, and it'll show you a list of all the books that are currently in here. And things pretty much work as you would expect. So I've got the main thing to note about this is that I've got an endpoint over here, and in the solution, it's in the books module in the riverbooks.books class library. And this endpoint is wired in to this web front end with just this one line of code with that books module service. And so what that extension method is doing, let's take a look at that, is right here. And so it is just saying, here's my connection string. It's using the books connection string. It's adding a books DB context and adding a couple services. It's going to opt into mediator stuff because we're going to use mediator for some communication. And then it's got that log message telling me it was registered correctly.
Okay.
For fast endpoints to work, I didn't have to do anything. It automatically goes and finds all of the things that inherit from those classes. So I kind of got that for free. It's one of the reasons why I like that library. The other thing that I'll point out in here that might not be obvious is this integrations folder. So, most folks have an understanding of like endpoints. Okay, that's what those would be. And data, that's going to be, your EF core stuff and your DB context. Integrations is my own convention for where I want to put the public facing pieces that integrate with other modules. And so I already mentioned that there's this idea of contracts, and that is in a separate project. And so the contracts project has things like the book details query. And this is a way that another module could get information about a book if it needed it, would be to create a query and then use Mediator to send this command. Now, when you send this command, it's going to end up hitting something that's in this integrations folder, and that's where this book details query handler lives. Now, this thing is internal, so nothing can call it from outside of here. In fact, the various services and repositories and things that are in this project, they're all marked as internal also, or they should be. If I missed one or two, that's my mistake. But the idea is that the only way that other modules would be able to talk to logic inside this module is through Mediator and through those contracts. And then these handlers will respond. So to see an example of that, let's look at the shopping cart. So there's another module, which is the users module. And I decided to just put the shopping cart on the user. And so there's a shopping cart endpoint where you check out. And in the checkout endpoint, it's got a request and a response here as well. But I decided a couple of different things here. One, I decided, actually, wait, maybe that's the wrong one. Maybe it's add item I'm thinking of. All right, so let's look at add item first. We'll look at checkout in a second. So in add item, if you're posting to an API and you want to add something to your cart, you would like your cart to show you the cost of the things in your cart, right? So like a shopping cart item should typically have these types of things, and one of them should be the unit price and the quantity. Now, if I just define this API endpoint and I say, hey, you can just post a cart item to me, right? And I know my application has the right price in it. So when the user clicks the button and sends me a post with that in it, I know that that's going to be the right price, right? There's no way that some user would ever, think about changing the price and posting a different price to my API than what they should send, is there? No? Never, yeah. So in this add item endpoint, the cart item request that goes with it doesn't actually include the price. It just includes, here's this book ID that you're trying to purchase, and then how many of them do you want? I'm not going to let you tell me what you think the price ought to be, even though it might be coming from my own front-end application. What that means that in this users module, somehow I have to get that price data. That price data is in the books module. Okay, so inside of this endpoint, I'm going to create a command to add this item to the cart, and this is going to get sent internally for this module. And I've organized things into use cases. So a use case is adding an item to the cart. All right, so we can talk for a moment about use cases. Use cases are sort of orthogonal or separate from Modular Monolith, but they can be a nice way to organize your code because it makes it really easy for you to deal with cross-cutting concerns through the use of your own chain of responsibility pattern implementation. And so I really like this pattern for that reason. But in here is the handler for adding an item to the cart. And this is just using Mediator. So this is iRequest handler means it responds to the add item to cart command, and it returns back a result. Now, this result type is a NuGet package that I have called ardalis.result. There's other similar packages out there. You don't have to use mine, but I know mine best, so that's why I'm using it here. And the idea with this is that instead of returning void and just throwing an exception if something goes wrong, I return a result where I can say what the problem was, if there was one. I can return with success, I can return invalid or not found, or other things that give you a little more information about what the issue might have been. And it works really well if you're using this approach with Mediator.
Okay.
So how could we talk from the shopping cart section or module of the application to the books module? Well, we could just add a project reference and go get the book info, right? And that would be fine once. But then if the book module ever needed a reference to anything in the users module or the cart module, it would need a project reference, and we can't go in two directions. So we'd be out of luck. Another option would be that you could use reflection to dynamically go and get the thing, right? You could say, well, I know that all these assemblies ultimately are going to be sitting in the same folder. So I can just load the assembly that I need with reflection and go and find the thing and call it that way. And you can do that. And I show an example of that in the course, but it's really nasty code and you don't want to do that. And you'll be tightly coupled and you won't have any compile time checking, and any refactoring you do will break it. All kinds of reasons why you don't want to go there. So what you want to do is you create a book details query, and you just call mediator.send to get your result.
Hmm.
And if it's not found, then we can say this was a not found result, and we'll return that. And again, that's using the Ardalis package. Otherwise, we're going to get the book details off of here, and we can add this to the shopping cart like here, and then save it, and then we're done.
Nice.
So if we just put, say, a breakpoint here, and I'll just debug for a moment. Once you start talking about mediator and messages, a lot of developers think, okay, but now I've still got to deal with this out of process message bus and RabbitMQ and whatever. And that's not the case. And I just want to make that clear with this debugging. So in here, if I go find where I add an item to the cart, which is right about here, hopefully my token is still working. We'll say send this request, and the token is not still working. So we're going to log in, and it's going to give me a token. And I'm going to copy that token out of here. The one thing, these HTTP files, well, I guess they kind of have the same support as Swagger with this variable approach, but maybe I just need to make my token last longer. It seems like I'm having to do this step a lot. But anyway, let's add this item to the cart, and we'll skip past that one. I don't need that one. And here we are. So we're inside of add item to cart handler. And if we step past this one and then into this one, it's going to take us into first this logging behavior, which we don't really care about. And then another behavior. And here. Now, where am I? Still in the logging behavior. All right, hang on. I need to just put another breakpoint where I want it to go. Sorry. All right, so in these behaviors, we're going to do some logging, and I'll show you those in a minute. But at this point, we're going to go to the next piece of middleware in our list, and that's going to be the validator. And I screwed up and went too far. All right, so let me do what I should have done already. I'm going to come up here to this books module and its integration here, and we're going to put the breakpoint where it should have been, which is right there. And we're going to come over here, and we're going to say, actually, add it to the cart again. All right, so now we've hit the query here, and we're just going to say continue. And then you're going to see, look, we're actually in the books module for the books query handler. So we stepped, like, obviously we hit a few other things along the way, but we didn't go out of process, right? We didn't have to go call some other thing. I didn't log a message on a bus, and then some other process had to pick that thing off a queue, right? With Mediator, it's all happening still in the same thread, in the same request. And so you're not having to deal with anything like, well, what if that other service is down, or what if the queue doesn't work, or any of that stuff. Like, it's still just running as if it were all in normal method call land, but we've got this mediator in place to make it so we don't have that direct knowledge or direct dependency on the thing that we're calling, right? So this handler here that's doing this work, the shopping cart code, the add item to cart code, doesn't know anything about it, and that's the beauty of that pattern. Okay, so we added those things, and those worked. And so now let's look at what those other pieces were doing. So we'll stop this for a moment because it's really slow, and we'll run it without debugging and just add the item to the cart one more time. And then let's look at our log output. So inside of here, we can see that we're handling the add item to cart command for this book for 2 items. And then I go and I have a book details query that it's handling for this book, where it's going to go get the price data. And then it says, I'm done with the book details query, and I'm done with the add item command. So we got this logging in there, but we didn't have to actually write that. So if you look at my handlers here, we look at the add item to cart handler, right? There's no logging happening here. Right? There's nothing in here to say it was done or anything like that. That's an example of a cross-cutting concern, where if every one of your methods starts with, log starting this method, and then at the end finish this method, that's something that should be a code smell for you. That should be telling you, hey, there's probably a better way to do this. There's probably a pattern I could use. And so for this, I have a behavior, and a behavior is a mediator thing. So we're using mediator here, and we're using iPipeline behavior. And what an iPipeline behavior does is it's just like middleware in ASP.NET Core, meaning it's a piece of code that every request will go through on its way to the underlying handler. Right. So when you build endpoints, whether you're doing it with MVC or you're doing it with API endpoints, you can add a bunch of middleware that's going to check authentication and authorization and debug stuff and exception middleware and all those things the request is going to go through. Then it's going to hit your endpoint, and it's going to come back through all those things again on the way out, right? So this is the chain of responsibility design pattern. That's what that's called. ASP.NET Core uses it. It's baked into middleware. You can use it yourself if you organize your code as use cases. So that's the reason why I have these separate use cases here, is because each one of them has a command, which is an iRequest, or a query, which some of these have, like get by ID is a query, which is also an iRequest. And because they're using Mediator, I can leverage these pipelines to add things like logging, validation, authorization or authentication, etc. So anything that you want to have happen every single time for every single call, you can put into this.
Cool.
And so the logging behavior goes and actually just shows me all the properties that were sent on a query or on whatever the DTO is. You wouldn't necessarily want this in production because it is using reflection to do that, but it only does it if logging is enabled at that level. So you could put this in like, trace or debug and then, not worry about it. And it also does a stopwatch so you can see how long it takes to do the underlying handler. And then it'll show you at the end of that, like how long it took. Now you get some of that at a high level just out of the box with ASP.NET Core, where it'll tell you that, such and such endpoint took 500 milliseconds. But it doesn't tell you what each thing inside took. Whereas this will give you that granular information.
Very cool.
And then similarly, the other one that you saw that it stepped into was this validation one. And so it's doing fluent validation on every query or command that passes through the pipeline. And so if you define a validator, like I have one up here for add item to cart, there's a validator that says, hey, the quantity must be at least 1. And so if I jump back into this and I say, well, let's add 0 items into the cart and we'll send that request, then we'll get a 400 badge request, which we should, that's telling us about the quantity. Now, you could do this at the API level, and maybe you should, but it's nice that you can also put it inside of your individual internal use case things, which have no dependency on ASP.NET Core or fast endpoints or whatever your front-end API technology might be.
So question or comment from Lazamat. I like the concept, but tons of folders with so many abstractions, a nightmare to learn and get everyone on a team on the same level. Isn't there a friendlier way to organize the folders and files?
That is fair, right? It's not a trivial amount of code or pieces. The main thing that you're getting here is that separation of the individual modules. Right. So if I built this and I didn't use a modular monolith and I just built it as a typical layered architecture, then I would probably have far fewer types. Right? I wouldn't necessarily have commands and queries and use cases. And to be fair, I added those because I really like the chain of responsibility pattern. So that's not necessary for modular monoliths. But I would have all that coupling. Right. So I'd have fewer, bigger files. And for me, I am much more comfortable when I need to add a feature to be able to say, okay, for that one feature, for this one endpoint, we need to add an update price endpoint. Okay, well, what does that look like? Well, it needs a book service and it needs to call the book service with the new price, right? And that's it. So are there a lot of files in the whole solution? Yeah. Do I need to look at all of those when I'm working on one feature? Not at all. Right? The whole idea is that when I'm working in the books module, all I know about are books and maybe contracts that other things need to work with. But if I don't need to integrate with anything else for the particular feature I'm working on, I'm literally only concerned with what's in this one project here. And so if there's other endpoints or controllers for products and services and whatever else, right? You've got 100 different API endpoints. I only care about these 5, right? That's all there are. What about all the different services and things I have to wire up? I have to look at program.cs and see where it's registering it, and I have to scroll through 3 pages of all the services that my application is trying to wire up correctly. Well, in here, I only care about the services that this module's using, right? They're all in one place. They're all right here. So the learning curve in setting it all up the first time, yes, it's not trivial. When I started it the first time, by the way, I only had this one module, so it wasn't that bad. But I've since added over many hours these other modules just to show how that's done. But when you're doing your day-to-day work, you might be on the books module team, in which case this is all you see, right?
Right.
Or even if you're responsible for the whole thing, you're only responsible for fixing that one bug in one of those endpoints in one of those modules, right? So you don't care about all of it. You can focus in on just what you care about and have minimal amounts of what's the word I want, of confusion of having too many things all grouped together.
Right. So harder to set up, but then a lot easier to work with later on.
Yeah. And still simpler than microservices, right? If I were doing this exact same thing with microservices, I would still have just as many moving parts. But now, just to launch the app, I'd have to have Docker Compose and a whole bunch of different ports. And if this module needs to talk to that module, I need to make sure it makes an API call or put something on a message bus and something else is polling that. And it becomes a much more complex thing to get that same modularity with a microservices solution.
Yep. So is this code in a GitHub where people can look at it?
At the moment, this code is only available with the course. I
Okay.
may make it available in the future, but it's not public yet.
Okay. And we will have the link to the course. Actually, can you pop up that slide for a sec?
Yeah.
Is it still around?
Sure. So Shift F5. There you go. So that's the bundle that has 2 courses in the bundle, and the bundle is 20% off. If you use Ardalis at checkout with individual courses, it'll give you a 20% discount too. So if you only want to try the getting started course, you can just put in Ardalis as a coupon code, and you'll get 20% off there too.
Okay, cool. And then I have another question about performance. Will the modular monolith have an edge over microservices?
It would. It certainly would, because just like a monolith would, right? So a monolith that is doing all the work in memory, in process, is going to be far better from individual request performance than a microservices-based approach where you have an entry point service that has to make a call to another service that maybe calls another service, and then all those round trips stack up before you can finally return. So having everything in memory and in that single monolith will be better performing generally.
Okay.
Now, performance and scalability are different things. So like I already mentioned, Monolith has some advantages on the scalability side, but for pure performance, having everything in one process is always going to win over multiple trips over the network.
Okay, cool. All right.
We still got a few minutes left, so I can keep talking about code if you'd like.
Sure.
All right. So something else that you can do in your monolith, which I thought was an interesting way to do things, is to set up a microservice / background service. So not a microservice, but a background service for sending emails. For a lot of my clients, I do help them build microservices for doing the same thing. So that's why I've got that on my brain. But I created for this sample an email sending module whose whole job is just to send emails. And so in this module, we're going to work with MongoDB just to show that you can have different persistence backends. It could have just as easily been SQL Server. And we're going to set up whatever the services are, but then there's a background worker that's going to be doing the sending. So when you need to confirm someone's order or you need to welcome them to the application, you send them an email, instead of any one of those endpoints doing it directly, it's going to do it with this module. And the way it's going to do it is by using this contract to send a command. So here's the command that we're going to send. You're going to get back a GUID that represents the email, that actual individual email that you could then go and look up later and see what you sent. Because sometimes customers say, hey, I never got your email. And you check your spam and blah, blah, blah. Right. You can check this and it'll actually tell you whether or not it was processed or when it was processed. And then the module also has an endpoint where you can list all the emails that were sent. So you can hit that over here somewhere. You can say list emails, and then it'll show you here's all the emails and when they were processed. Obviously, this would be a lot bigger if there were real emails, but these are pretty small. And then the background service, I put everything in this one folder. This module, I decided to use the vertical slice architecture approach. And so these integrations, like queuing up the email, everything you need for queuing up an email in the outbox is in this one class. So you can just kind of scroll and see, here's all the things that do the work. And so you don't have to bounce around and see, to the point of the questioner about, hey, aren't there a lot of files, right? Well, if you organize it using vertical slice architecture, at least in this one piece, right, everything you need is right here. There's this interface, there's the implementation of the interface in the same file, there's a thing that uses the interface right here in the same file too, and so everything is right here. Likewise for the background service, the background service is right here. It uses an email sending, that's the logger. It uses this send emails from Outbox thing. And so this service, this is what basically every background service should look like. It has a while loop, and it tries to do a thing, and it logs if something bad happened, and then it waits until it's time to do the thing again, right? So this is going to go every 10 seconds. And inside of here, you'll see it's sleeping, right, while it waits for something to do.
Okay.
And then if there is something to send, then that's this right here. It's going to go and grab the thing, in this case out of MongoDB, says, give me the first thing in there that hasn't been processed yet, and then go ahead and send it. So in here, we're going to say, hey, send the email. And so for me to send an email, I just need to check out. So I added some things to my cart before, so then I can say, where's checkout? I can say check out my cart, and it checked out. And now if we look at this thing over here, the next time it wakes up, it's on a 10-second delay. It should see that there's a thing in the outbox that needs sent. And for a real background service, this would be more like every 100 milliseconds or something, not every 10 seconds.
Right.
But it should, oh wait, I didn't scroll all the way down. There we go.
Ah, there it is.
There we go. So now it's attempting to send the email, and the email is sent. And then you can use a tool like Papercut. Let's go over here, go to Papercut, and then you can see, hey, here's my purchase right there. So like this just came in. So Papercut's running as a Docker instance on my machine, and it's a test email server that will capture emails without actually sending them. And it's free. Like it's literally one line to run this thing. And then you can see your email. So you can really send emails from your application using localhost, and then this will let you see what it looks like.
That is neat.
Yeah, it's a cool little tool. So everything you need to run
a conference talk before on Graph API, and the code actually sends me an email. So on the one hand, I'm getting emails from people that I don't know, but at the same time, it shows me that people are still using the code. So I actually enjoy it.
Yeah,
because it's not that, it doesn't happen that often. But if it happened all the time, I would have wished for a different approach. So that'd be a pretty good one.
Yep. No, I used to do that too. And now I use a different email than my own. So when people are testing this thing out, it's like, nope, that's not really my email address. steve2@test.com.
Right. Cool.
All right. So any more questions? I think that's about all we have time for.
Not at the
I
moment.
put a ton of time and effort into this sample and this course. So I hope that people enjoy it and that it's useful. It's a lot of lessons learned from me that I've tried to put into this from different clients and applications I've worked with. And so I think it does work well for a certain Goldilocks level of complexity between the regular monoliths and microservices.
It makes a ton of sense, actually. So yeah.
And it's really easy. Like you can imagine that this module right here for email sending, there's absolutely no reason that this couldn't be a separate microservice if it needed to be. Right. And then all that would change is that this command would have to go over Azure Service Bus or something instead of using Mediator. So it'd be trivial to just put that into its own separate process, host it somewhere as a microservice, and let it pick up these commands from Azure Service Bus or RabbitMQ or whatever you like.
Yeah, that's awesome. Thanks so much for coming on the show and walking us through this. We'll have links to the course and anything else. I'll put those in the show notes. And this makes a ton of sense. And it's a good thing for people to check out. So thanks for doing this.
All right. You're welcome. It was fun.
All right. Hope you guys enjoyed that. And we will see you next time on Visual Studio Toolbox.